When you project your spirit underground looking for something and it finds it, a marker field will form on that object. Let's say that you're looking for the element of copper, the metal copper. And here we have an example. This is a 2017 copper penny, stuck to some masking tape onto a shish kebab stick. Now this is copper on the outside, it's got zinc on the inside, and the reason I have it on a shish kebab stick is if my hand is within 6 inches of it, I will pick up the ion readings. So I have it on this little silly flag here for this demonstration. Now, when I'm ion testing, I cannot test food like inside of a can because the metal will interfere with it. But I can actually detect with the ion readings, I can detect the zinc inside the copper. For some reason, metal inside of metal can be detected, but not food inside of like a tin can. So what we're going to do here is I want to demonstrate this. I'm going for the zinc that's inside, and I'm going to be using the ion field. There's zinc. Zinc. Right there, the zinc reading stops. I've extended myself beyond the reach of the ion field that goes off the end. But now watch this. We're going for copper, and copper is what's on the outside of this penny. Copper. We're at the range where the zinc gave out, where copper, copper. The copper continues on because the copper is on the outside, and this is what I'm actually going for. And let's go for underneath it. Copper, copper. The copper reading is underneath it. Most people don't realize that the marker field goes up and down. I've actually been in a cave, a limestone cave in Springfield, Missouri, and was ion testing for gold, and there was actually particles of gold that was in the limestone ceiling, and I was picking up the marker fields that were coming down from the ceiling. So the marker fields run up and down, and the marker fields do not form if there is a metal encasing. It doesn't pick up what's in the center of that. But also, the marker fields have difficulty if they encounter an even dispersion of a particular metal. This thing I'm showing you here is actually my pillowcase, my Grounded Beauty pillowcase that is hooked up to the batteries of the truck. It gives it a negative ion charge and helps to pull positive ions out of the body while you sleep. But anyhow, it's a weave of silver in there. But if I take this, and we're going to stuff it right under there. So we've got right there. I can feel it. And let me push it down. Maybe you can see where that penny is right there. So we're going to go for the ion reading. Zinc. Zinc comes through just fine. Let's go for the copper. Copper comes through just fine. Now we're going to go outside of the ion range. Copper. Still got it right there. I lose the copper. Now, before, the copper reading would come up with the marker. It would rise up with the marker field, but the marker field cannot get through this even dispersion of the silver. So what's happening is the marker field will look for an escape, and it will rise up almost like a gas, like a light gas. And let's see where it's coming out here. Copper, copper. Right about there. I'm actually getting the copper is coming up in a wide band here. And one thing that's frustrating if you're dowsing, if there's a lot of metals in the ground, what you're dowsing for may come up in a very wide area. I've seen it come up as much as 10 feet across. And if you're using dowsing rods or even with a pendulum, you try to you try to find a field that's dancing all over the place because it's wicking its way through the ground. It can be really frustrating, very frustrating. Let's actually lift this up a little bit to give it an out, easier out for that signal. There we go. And now we've got the copper reading steady, coming right out there. But the marker field is rising up and going to the highest spot and then coming up from there. Very fascinating. Now, let us go and look at plastics. I can read copper through insulated wiring, like this extension cord. I have no problem with it. But the reason I can is because this plastic does not have much for metals in it at all. But you take something as simple as one layer of a Walmart shopping bag, which is it's a special plastic. It has actually tin in it, an even dispersion of tin. And we're going to set this right in there, inside of that Walmart shopping bag. And we're going to do the same thing that we did with the silver weave pillowcase. We're going for zinc. There's the zinc. We're going for the copper. There's the copper. We're going to see if we can find the marker field. Marker field is gone. Where is it coming out? It's coming out right there. Because even one layer of a Walmart shopping bag has enough even distribution of the tin in it to cause that field to have to make a diversion. When I was researching the horizontal fields in tracking that would come off of a dowsing rod or Y stick or off the nose of an animal, that field is not blown by wind or water currents. It is only moved by the anion charge, particularly of the earth, because the mantle of the earth has a negative ion charge, and there's a layering of the anion intensity that decreases as it goes away from the earth, but it's stronger like in trees and stuff. And whatever anion layer that is the signal is sent out in, the tracking field, it will try to stay in that layer. And what this allows it to do is that it'll go up over a hill and down into a valley, trying to stay in that anion layer that it was sent in, and it will avoid trees. An animal going down into a tunnel, like a rabbit's tunnel or something like that, the anion charge off the predator's nose will not disappear into the ground. It will follow the tunnel itself, try to stay away from the edges of the tunnel. Similarly, the marker field is not blown by wind or water currents. Now, this was interesting for me because one day I was testing this. I was out in a stream and I was dowsing for gold, and there was a fine flower gold in that area, and I was up to about my knees in the water current, and I detected underneath a stone gold, and I rolled the stone over and I tried to grab the fine flower gold that was on there, but it slipped right through my fingers. I needed to have a siphon or something to suck it up. I didn't have the right equipment, but it was really fascinating that even knee-deep water with a stiff current flowing, that the marker field was not affected at all by the wind or by the water itself. Now, it made me wonder if it's for the same reason that the horizontal tracking field is not affected by it, but it makes me suspicious that there may be other reasons with the marker field, because the other fields that the marker field revealed have an interaction, a unique interaction with air and water. So the marker field runs up and down from the object that you're searching for, that it finds. It is not affected by wind and water, but it is affected by what is in the soil that can cause it to dissipate into different directions and to dance when it gets to the surface. Here's an example of this. Right here, I have a penny. And I have this set about as level as I can. And I'm going to go for the copper reading that's coming up. There's copper, and I can feel it's very faint. which means I'm not getting a concentration of it. I'm getting just a little bit of it all along the edge here. And what happens is it's coming up, you know, just a little bit here and there. It's going to try to reconstitute itself as it comes up. And that's where it dances, as it tries to reconstitute itself, because it's almost like a flame, a flickering flame. And we're going to go for a copper reading here, and there we have the copper reading, and there we don't. Slight copper reading, nothing. Strong copper reading, nothing. And what's happening is it's reconstituting itself. That field is moving back and forth like a flickering flame. So I'm in the flame and I'm not in the flame. I get a little corner of the flame and I don't get any of the flame. So if you're out there dowsing and looking for something underground, you can really get frustrated when you run into one of these dancing fields, because it's moving all over the place. It's very hard to track. And although there is something underground that it is detecting. But what I found is, if I have a dancing field, if I take crystals, and these are just quartz crystals, and I scatter them on the ground where I've got the dancing field, it changes. It's like it changes the lubricity of the marker field. It's kind of like switching your car from regular motor oil to synthetic motor oil, and you know that if you have a slight oil drip, you don't go to synthetics, because the synthetic motor oil would just flow right out through that slight drip because the lubricity is different. Similarly, putting the crystals seems to change the lubricity of the marker field, so it slips easier through the ground and does a lot less dancing. Let's see what we get here. We're going for copper. I have a copper reading here, a solid copper reading, and a steady copper reading. Let's see if we get any more. It's right there. So instead of it dancing back and forth, now it's coming up through the center here, and it could be just a little bit higher on that center, but it's no longer dancing. Let's check it up higher. Yeah, it's solid all the way through. So there is an interaction between the marker field and crystals. Now, when I was doing my dowsing research, I noticed a video on YouTube entitled Dawkins Debunks Dowsing, and in it he set up a test tent area with things for dowsers to find, and the dowsers came in and they could not find anything. And I was really curious as to why this was, because when I do dowsing on my own, I have absolutely no trouble. And so I was curious if it is possible that in preparation, as Dawkins was setting this up, of him telling people that he's going to be debunking dowsing and there is no supernatural, this is all nonsense. I was just curious if his speech, if his words had any effect upon the marker field. And I found out that it absolutely does. That words like "this is stupid," "this is dumb," "this is nonsense" will cause the marker field to disappear. So let us go back to this test. Here we have the copper. I have a penny under here with a piece of tape on it, so I know exactly where it's at. And because the physics get really strange with the Dawkins effect, and here's a penny that's sitting on top. If I go for the copper reading, there's the copper reading, nice and strong. And then I induce the Dawkins effect. This is not real. I go for the penny reading, and here I've got ion reading within 6 inches. The Dawkins effect does not change the ion reading. But if I go for the marker reading, copper, I'm outside of the 6 inches, so it's no longer ions. Copper, nothing. Now the thing that's fascinating here is I can say this is real, and we go copper reading. There it is. There's the copper reading. Now it gets even weirder because under here I have a penny, and it is, because it's under there, it's a dancing field as it comes out of here. But notice this. This is not real. I'm inducing the Dawkins effect. It's going to affect that penny, which is exposed. But we're going to go to the dancer, and we're going for copper. And we still have the copper reading. The Dawkins effect does not affect a dancer. But to make things weirder, let's take this penny and put it directly over that penny. And then we're going to do the Dawkins effect again. This is not real. We're going for the copper reading. It's gone. For some reason, the copper next to that was able to induce that effect through the silver weave. Well, let's take this out. And we're going to say this is real. So we're going for copper reading. The copper reading, the marker has returned. But if we don't have a dancer going here, let's pull this up just slightly so that it constitutes itself into one solid. Come on. There we go. This is real. We're going for a marker for copper. There it is. And let's do the Dawkins effect. This is not real. Copper, nothing. So if it's dancing, it is immune to the Dawkins effect. If it is not dancing, then it is subject to the Dawkins effect. And I have no clue. Now here's an experiment that you can try. Take 2 coat hangers, and this one I already cut. But what you want to do is measure 13 inches, which is a good length, this way, and 6 inches that way, and then cut them. So they're 13 and 6, and then straighten it out so it's a 90-degree angle, so you're going to have 2 dowsing rods. Now that you have the dowsing rods, hold them very loosely in your hands. You don't want to grip them real tight, just kind of hold them real loose, and hold the tips up enough to where they're just wanting to swing on their own, because if you hold them up too high, they'll just flop right over. You want them just below that point where they're going to flop over on you. Now, let's try this. I've got a penny down there. You could put a penny on the floor or copper wire or something like that. And you say, yes, 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 this is real. And meditate or concentrate or say copper, 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 copper. Let's see here. I get the crossing right there over the copper. Try it several times. One of the easiest things to get the reading on is actually like the edge of cement. If you focus on the edge of cement, because the structural change is a lot easier to pick up with dowsing, like the edge of a sidewalk or the edge of a road. So let's try this again. We're going copper, 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 copper. And we've got the marker filled right there. Now I'm going to see if I can induce the Dawkins effect. This is not real. This is stupid. This is nonsense. And we're going for copper. Nothing. And you could try that even with the edge of a sidewalk. Trying for the copper again. Nothing. This is real. This does work. This is real. Copper, 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 copper. And there we get the reading again. But you can experiment with this to see if you can induce the, first of all, to get the readings this way, and then to see if you can induce the Dawkins effect. And one of the things that's fascinating about the Dawkins effect was I discovered that it travels from the point of where it is spoken about 1.5 miles an hour. So that 100 feet, it took about 50 seconds for that effect to get there. And what you can do with that experiment is you can actually go outside, set down pennies at 25-foot intervals. And you can do this thing where you're saying, yes, it is real, and then go for the copper reading and say, no, it is not real. This is nonsense. And see if the Dawkins effect has affected your ability to read it. And then hustle down to the next one that's 25 feet away. See if you can get a reading on it and see how long it takes the Dawkins effect to get down to that one. But what I found is that 100 feet out, it took about 50 seconds. You can also do this along a 100-foot stretch of sidewalk. You know, put down marks on it so that you know where 100 feet out is, and then 100 feet away, induce the Dawkins effect, and then run down 100 feet with a timer and see how long it takes for the Dawkins effect to get down there. But I found with my experiments, it takes about 50 seconds. But what is the Dawkins effect, and how come it does not affect a dancer? When the field is dancing across here, I can speak all the negativity that I want. It will not affect it. But yet if this is opened up, it will affect it. So it made me suspicious that it has to do something with sizing, because when a dancer field is coming out, the marker field is broken up into smaller segments, smaller pieces. And so as an experiment, what I did is I took a cottage cheese container here, put a penny inside, and I started cutting holes, and I found out that a half-inch hole, half-inch across, I can get the marker field, copper, the marker field comes across, but if I plug it at all, copper, nothing. I do not get the marker field. So the marker field requires a half-inch gap, half-inch opening. And so when it dissipates in the soil, it's actually looking for a 1/16 of an inch here, a 1/16 there, a 1,000th of an inch there. It's trying to work its way up so it can get a total of a half-inch opening to get through the soil. That's what causes it to spread, and that's what causes it to dance once it reconstitutes itself. Also of interest here was the Dawkins effect, because we're going for copper, and we induce the Dawkins effect. This is not real. Copper, nothing. This is real. Copper. And also you will notice that Dawkins effect takes a couple seconds for it to actually occur. But we've got a copper reading here. Now, this is half-inch. I'm going to reduce this down to below half-inch, or below half of that, below 1/4 inch, and I'm going to try to induce the Dawkins effect. This is not real. Copper. Now I'm going to reduce it down less, or not all the way half. So we're about that much. This is not real. Copper, nothing. The Dawkins effect requires at least a 1/4 inch opening, where the marker requires at least a half-inch opening. So it is very unusual. Okay, this is real. And there's our copper reading. Now, I'm going to reduce this down just to a smidgen. I don't know if you can see what we got there. Just a little bit of an opening in there. There we go. And of course we've got nothing. But now we're going to take a piece of crystal and copper, and the copper reading can get through that little bitty wedge of an opening that you can see right there. The copper reading can get through because of the presence of that crystal.